A very good afternoon to one and all present here. On behalf of Department of Biomedical Engineering and the Department of Electronics and Communication Engineering, Arupadivid Institute of Technology, Chennai, I welcome you all for the workshop on Internet of Things. In this regard, I would kindly request Dr. L.K. Hema, Professor and Head, the Department of Biomedical Engineering and Electronics and Communication Engineering, to present the welcome address.
Thank you, Lakshmi Shri, the coordinator of this program. Very good afternoon to one and all joined here for this virtual workshop on Internet of Things. So, as a faculty, as a professor of EC department, now as an additional charge, I have taken this biomedical department also. So, on behalf of AVIT, EC and biomedical department, it is my privilege to welcome you all to this virtual workshop, which is going to give an overview as well as the functionalities of Internet of Things. So first of all, let me welcome our today's guest speaker, Mr. Mogana Sundaram, who is an embedded developer, going to give a lot of inputs on Internet of Things. Now, Internet of Things is one of the bus area, that is the area which is going to be learned by everybody. So it is having impact on healthcare, especially in healthcare. For example, if you want to monitor the vital parameters of a patient or a soldier who is trapped in a convenient situation, you can monitor the vital parameters like body temperature, the saturation level of oxygen, then heart rate, everything you can monitor. And those information has to be transmitted to the remote physician. Then you need the support of this Internet of Things. So in addition to the sensor technology, you have to have the idea how the data, sensor data have to be transmitted to the remote physician as well as the family members. You need some controller, how to do the data processing, how the data has to be transmitted to the remote physician and family members. All this involves in the Internet of Things. So this is one particular application in healthcare where Internet of Things is playing a vital role. Okay, so similarly, now Industry 4.0 is focusing based on our Prime Minister's Atmanirbhar scheme. We, the academicians as well as the students fraternity, are involved to develop lot of projects which are used for the societal benefit. Okay, so under the Institution Innovation Council, the students are made to develop some projects or prototypes that can be converted into a product which is useful for the society. So it involves some electronics as well as you must need the physiology. As a biomedical engineer, you must be aware of the physiological parameters, how it can be processed to the processed and can be converted into a useful information shown as an output. Okay, so these are the avenues where Internet of Things are playing a vital role. As I mentioned, in Industry 4.0, we are monitoring the processing that is happening in various industries. Without human intervention, with the sensor technology, you can monitor the informations and that can be processed. Then the control actuation can be enabled. So these are the two applications I'm mentioning. It is having wider impact in all domains. So Mr. Mogana Sundaram is here to give a good insight about the Internet of Things. I think he'll be starting from the scratch, and he'll give an insight about the Internet of Things to you, so that you can carry out your mini project and other IIC prototype development, then Vishwakarma Chhatra Award. It is also the challenges now open to the students. So to submit ideas to these forums, you must gain the knowledge. So to facilitate this, we are coming up with these kind of programs to the students' fraternity. So it is my privilege to welcome Mr. Mohan Sundaram sir, who is going to present the topic. Next, I extend my hearty welcome to our Professor Dr. Vijendra Babu sir, Vice Principal Part-Time Studies and Professor in EC Department. Sir will give more insight about wearable technology. Now he has chosen the domain of wearable technology. So he is here with us to give, to share the informations on wearable technology to the electronics as well as biomedical engineers. Welcome you, sir. Next, I welcome all the student participants from biomedical engineering as well as in electronics and communication engineering who are joined here to gain the knowledge about Internet of Things. Next, I extend my hearty welcome to all the faculty colleagues and the participants from other institutions also. So those who are not able to join in Zoom link, you can join in the YouTube live. So you kindly share the information to the participants also. So I welcome you all to this wonderful event. Thank you. And I am handing over the session to Lakshmi Shri, Madam.
Thank you so much, ma'am. Thank you so much, ma'am. Now, I request Dr. Vijendra Babu sir, Vice Principal Part-Time Studies, to deliver the special address.
Thank you, Lakshmi Shri, Madam. Good afternoon to all present here. I sincerely welcome our chief guest of today's event, Mr. Mohan Sundaram from RETEC, who is going to handle this session. We are happy to collaborate with you, sir. Hope your session will kindle the young minds to get into focus on the real-time applications and hands-on training on IoT. Thanks for your accepting our invitation.
Thank you.
I sincerely thank HOD, EC and Biomedical. Yes, thank you, sir. Welcome. Dr. L.K. Hema for giving this opportunity, and best wishes to the organizers of this, Ms. Lakshmi Shri, and all the members of EC and Biomedical to conduct this program. And best wishes to all the students who have been here. The department has chosen the right topic of IoT and hands-on training. As we all know, IoT now is a very, as we talk about AI in another term, as IoT plays a major role. It's a very hot topic in current scenario. We talk more on IoT, Internet of Things, as we know that it's in connecting of physical devices. In the physical devices of various things we call, that becomes maybe a sensor or maybe a software. Majority will be an embedded system. So the speaker is going to play a major role in it, which is going to hold various technology. That's a basic thing now. So various interconnectivity and that plays a major role for connecting, exchanging of data, and how it is going to be processed with the internet. As we get into the IoT, the fast trends or hot trends in IoT, it's about the data which is going to be the growth in data and devices with human device interaction. As Madam has rightly said about wearable devices, as we all know that we all getting into Fitbits or health monitoring devices across us. Either we walk properly, either we drink water regularly, either if there is any irregularity with us, either it is going to be transmitted to the doctors who is going to monitor us, patient monitoring system, all this thing, telemedicine, which plays a major role in currently as one of the hot topics in wearable topics, and also about the voice user interface, which is going to be in very reality, like chatbots and all those things. And like we are getting into a device miniaturization, and then about huge amount of investments as we are with respect to business perspective also, and it is going to relating to also blockchain too, as we are getting into more huge applications for Internet of Things. It's a very great opportunity for the student. As I always say, that students should not focus on only our domain like ECE or biomedical. It's always a holistic, like an interdisciplinary approach is going to succeed for all the progress, like fitness trackers, which plays a major role, and even the small example of child and pet finder. infant monitor. We can see the problems are around us. By using the technology, using to the smaller level, we can able to succeed in product development, which also makes us for using our incubation center on our entrepreneurship development cell too. I hope this session will able to make the students interest to and shifting their interest to the next level. And to share about our curriculum, we are also having a specialization in IoT in our curriculum, where students can able to select the topics of 5 subjects in that. To be the degree will be a specialization of IoT, which is a specialization of our university, which is offering our degree. So this is going to be an add-on value to our initiatives taken by the academicians in university. I sincerely thank all the participants for here on this afternoon session, and thanks the organizers and best wishes for the program. All the very best. Thank you.
Thank you so much, sir, for your wonderful insights. Now, I request Ms. Sandhya to give a brief introduction about our today's speaker, Mr. A. Mohanasundram, sir.
Thank you, ma'am. Mr. A. Mohanasundram has completed his ME and embedded developer by profession. He has 3 years experience in teaching field and conducted value-added programs in St. Joseph Institute of Technology, St. Joseph College of Engineering, and also he conducted seminars and workshops in St. Joseph Engineering College, Sairam Institute of Technology, Tagore Engineering College, JPR Engineering College, Rajalakshmi Engineering College, and etc. He has completed more guest lectures and conferences in various colleges. DTech Solutions have encouraged and motivated the students' community to start new things in India. Programs like internships and implant training, seminars, faculty development programs, industrial visits, workshops, value-added programs, and awareness programs are conducted by DTech Solutions. Looking forward for the session, sir. Now I kindly request you to please take over the session.
Thank you, ma'am. Thank you. Hello, ma'am. Lakshmi, ma'am.
Sir, yes, sir.
Ma'am, post disabled participate screen sharing. Screen share பண்ண முடியல மேம் என்னால. அது மட்டும் எனக்கு கொஞ்சம்.
1 second, sir.
ஓகேங்க.
Sir, now can you check it, sir?
I have 2 devices, ma'am. One mobile phone for voice and system for screening this share the screen. So I think Mohanasundram.
Yes, sir. I've activated that only again, sir. Mohanasundram. Yes, sir.
But I have same message only, ma'am. Post disabled participate screen sharing like that.
So, on which name it has been showing, sir? Have you registered, sir?
Mohanasundram, sir.
That is the only thing which are showing visible here.
Sir, there's only one name, Mohanasundram. I've even made you as a host now, sir.
Yes, ma'am. Okay, wait, ma'am. I will check.
Okay, sir.
Mohan is there, na?
One Mohan is there, right? But maybe students will be there, ma'am.
Okay,
This Mohan is a student or your
Mohan is also me only, ma'am, because I have 2 devices, ma'am.
Okay. Which one you want to enable, sir?
I think Mohanasundram.
So that is made as host, sir. That is made as host.
Sir, Mohan Sundaram you are using for talking only, you told, na?
Yes, sir. Please.
But for sharing that one, you are telling something different devices.
Okay. Sir, please host to me. I will move. Wait, sir. Sir, please make Morgan as host.
Are you able to share, sir? So, Mohan Sundaram?
Just now Mohan is made as host.
Yes, ma'am. Okay. Wait, ma'am. Wait.
Yes, we can able to see.
Okay. Thank you, sir. Thank you. Very good afternoon to all. Internet of Things means IoT is a network of physical objects with embedded electronics that collect and share data. Okay. Before 5 years, before internet, we used some wireless technologies like Bluetooth, like radio frequency transmitter, radio frequency receiver, like that before use. Why IoT is most famous? Before that, we used first the communication is the main part in Internet of Things. Okay. Communication is before first we start the communication via like one-way communication. Like example means walkie-talkie. Okay, walkie-talkie is the one-way communication device. They used half duplex method for transmit the data from one device to another device. Okay. What is half duplex means? Only the transmitter or receiver only transmit the data. At the same time, we cannot transfer the data both method. Only the transmitter will transmit the data means the receiver receive the data. Okay. This is the one-way communication only. Okay. That one-way communication, then it will come for one mobile phone. Or for example, invented the one phone call. That device is full duplex method. At a time, transmitter and receiver also send the data and receive the data. Okay. Data means like numbers or speak audio is everything will be the one data in electronics. Okay. Then we used some wireless communications. Okay. Wireless communication means we used GSM technology for communicating one mobile phone to another mobile using CDMA method, code division multiple access. Via that method, we used transmit the data from one device to one mobile phone to another mobile phone. Then we used some RF, radio frequency transmitter and radio frequency receiver. Then before used to some distance only transfer data. Bluetooth will be the used for minimum one device to another device, like some distance only, like 10 meter, 20 meter. It transfer the one device to another using Bluetooth. These are also wireless. Then why Internet of Things will be most famous? Okay, Bluetooth also one wireless communication. RF, radio frequency, RF transmitter and RF receiver also wireless communication. Internet of also one wireless communication. Then why Internet of Things will most famous means we are using Bluetooth or RF transmitter means transmitter is there and receiver is there. Whenever the transmitter transfer the data means the receiver is get. Okay. At the same time, the receiver is not able to get the data, means the data will loss. The receiver does not hear, or receiver does not use the receiver side, means the data will loss. Okay, because transmitter data means the receiver is enable the data, means the data will get it, or the data will loss. Or I will give one example. Like before that, we used Bluetooth for transmit one song to one mobile to another mobile. First we pair the mobile using Bluetooth. First we pair the mobile using Bluetooth, then transmitter one song. Song is the data. Song is also one data. The receiver is get the data. Suddenly the receiver turn off the Bluetooth, means the off data only received from the receiver. Another all data are loss. Okay. In Bluetooth or RF, everything is same concept only. Transmit the data means at the same time, or otherwise the data will loss. Okay. Then we propose to like Internet of Things. Why Internet of Things will be famous means the Internet of Things intermediately have one source. That source is called cloud. Okay, the transmitter is there and receiver is there. Intermediately we have one cloud. So whenever the transfer the data, means that data first stored in cloud, then only transferred to receiver. Okay, receiver is there or not, no problem. Receiver is at a time, receiver is present or not present, that is no problem. Example, we used to lots of Internet of Things sources like WhatsApp, Instagram, Facebook, Gmail, everything have one special cloud. First we registered our numbers or everything, first we registered. Using WhatsApp means first we register our name in WhatsApp cloud, then we chat with our friends. Then first we send the message, means the receiver the internet, means the data will stored intermediately in cloud. The data will stored intermediately in cloud. The receiver does not, whenever the receiver turn on the internet, means the data automatically sends to the receiver. Then only Internet of Things. These reasons are the famous for Internet of Things, because Internet of Things have intermediately have one cloud. Okay, using that cloud we stored some data in cloud. At the same time, the receiver is have internet or not, if receiver is present, that is not a problem. But whenever the receiver use the internet, that time only the data will transfer to the receiver. Before that, we using wireless communication like Bluetooth, RF. They does not have that facility. Okay, the transmitter transmit the data, means the receiver is there. Receiver is present, means the data will received to the receiver. But receiver is does not. The receiver is does not present, means the data will loss. Okay, because that the wireless communication internet is the nowadays also internet will be very good famous. Okay, very famous. Wireless communication means Internet of Things also one wireless communication. But why Internet of Things only very famous means they have intermediately transmitter and receiver is there. Intermediately they have one cloud to store the data. Okay. Okay. Then we coming for how to transfer the data, how to read the data, and how to I store the data in cloud. That is the next question. Okay. You first starting from you just tell like data. What is the data? How to I send the data to cloud?
Excuse me, sir.
Yes, brother.
Sir.
Yes.
Sir, actually, first screen only we are able to see. Are you changing the screen, sir? All right.
Yes, sir. This only, sir. Then we change. Okay. Data means first we use one microcontroller. to read the data and transfer to the cloud. We used one microcontroller. Okay. What is microcontroller means? Microcontroller is based from the embedded. Okay, embedded means combination of both hardware and software. Okay, before that I will tell Internet of Things means IoT is a network of physical objects with the embedded electronics and that collect and share data. Physical object means like already ma'am is told, like patient temperature. That is patient temperature is the one data. First we read the data from one sensor from controller, then it will be transferred to cloud. Okay, first we read the data, then only it's then only transfer to cloud. Okay, the physical object means that is a physical object like sensor data or one module. That's our physical objects. Then embedded means we read the data using some programming language. Okay, you are using Arduino based Arduino IDE means we using the embedded C programming, or you are using Raspberry Pi means using Python. Raspberry Pi means Python, Arduino IDE means embedded C. Okay, based on that program only the controller will works. Based on that program only the controller will works. First we use one program to read the data from that sensor, then only it transfer to cloud. Okay, what is microcontroller means? One microcontroller have some devices like ADC. I have one microcontroller section. That section I will clearly explain. Okay, controller means what are the input you are given in programming means based on that program the controller will work. Okay, based on that program only the controller will work. Then
Sir, sorry for interruption, sir. The screen is like it's in the
Yes,
same
ma'am.
first slide, sir. Screen
Okay,
change
ma'am.
agala. Ipadan sir change aachu. Okay, sir.
Okay, thank you. Nowadays we are using some famous microcontrollers like Arduino and Raspberry Pi. These are nowadays the famous microcontrollers. Okay, before that where it start from? Okay, who is invented the microcontroller means Intel will invent the microcontroller in 1970s like IN4004. IN4004 is the first microcontroller invented by Intel. Intel is company first invented the microcontroller. That name is IN4004. Okay, that microcontroller is 4-bit microcontroller. 4-bit microcontroller. That microcontroller have lots of drawbacks. Okay, then only the drawbacks will be reduced. Now we have like one good microcontroller like Arduino, Raspberry Pi, ESP8266 microcontroller. Okay, then famous microcontroller first famous microcontroller means 8051 is the first famous microcontroller. Okay, but 8051 also have some drawbacks. We rectified the drawback, but nowadays we have one good microcontroller like Arduino. Okay, but 8051 is the first famous microcontroller that will be invented by Atmel. Atmel is the company. That company invented the 8051 microcontroller. Okay, 8051 microcontroller have some drawback. Some drawback means instruction set, ADC, PWM, timer, and UART. Okay, what is instruction set means? We already know, like instruction set means controller have some programming language. That language have some instructions. Okay, you're using Arduino IDE means Arduino IDE some instructions. That instructions are very difficult in 8051 microcontroller. Okay, total instruction set 256 instruction set in 8051 microcontroller, we program to we first easily start the 8051 programming. We definitely know the 256 instruction set. That instruction set we have only, we use that microcontroller 8051. Okay, that is the main drawback. Okay, 256 instruction is not a easy. Okay, what are the instruction set means? Like addition is addition, subtraction. These are arithmetic instruction set. Addition, subtractions are arithmetic instruction set. Move a comma b, add a comma b, these are data transfer instruction set. Like 8051 microcontroller gave 256 instruction set. That instruction is very difficult to use that 8051 microcontroller. Okay, now we have Arduino microcontroller. That microcontroller only gave 10 to 15 instruction set only. Okay, Arduino gave only 10 to 15 instruction set. Okay, 256 is very large and very difficult. 10 to 15 is very easy. Then only Arduino is very famous. Okay, then ADC. What is ADC means? Analog to digital converter. Okay, why ADC is important in microcontroller? Okay, controllers only know the digital values. Controllers have only know the digital values, zeros and ones. Controllers have only the knowledge of zeros and ones. But we definitely read the some temperature. Like we want to read the room temperature means, that is the room temperature is the one analog value. Okay, what is analog value and what is the digital value means? What are the values are changed with the time means that values are analog values. Okay, like temperature is definitely change with time. Okay, because morning time a one temperature and afternoon time a one temperature, evening time a one temperature, and night a one temperature. Every time temperature is vary. Okay, we cannot define temperature in zeros and one. Okay, we cannot define temperature in zeros and one because that temperature is the one analog value. Okay, then what is digital value? Okay, digital value we definitely define with zeros and one. Like one buzzer is there. I will give some example. One buzzer is there. Whenever you give the voltage means the buzzer is on. The buzzer is on means the buzzer give alert. The buzzer will give sound. We cannot give voltage means the buzzer does not give sound. Zeros we can define with zeros and one. Those all devices are digital devices. Okay, I will give another example like IR sensor. IR sensor is used for object detection. IR sensor is used for object detection. Whenever the object is detected, it will give the value 1. Whenever the object is not detected means it will give output like zeros. We define the output in zeros and 1. These devices are digital devices. We cannot define with zeros and 1 means that device, all devices are temperature and gas and water level. These all are analog devices. Why is very important in ADC means we definitely need the one ADC. Whenever you just give analog value to, we cannot directly give the analog value to controller. So only we need the ADC. ADC will change the analog values to digital value. Okay, first we give the analog values via ADC means that ADC will convert the value to digital. Digital is readable for controller. Okay, then only the ADC is most important in microcontroller. But unfortunately, 8051 does not have inbuilt ADC. 8051 does not have inbuilt ADC. If you want to interface some analog sensors with the ADC means we definitely need the MCP 3008 IC. MCP 3008 IC externally. If you go for externally means we give some extra voltage and extra space. These are some drawbacks. Okay, if you have the ADC inbuilt means that access the data very fastly, but we cannot behave externally means we cannot access very fastly. That is the big drawback in 8051. 8051 is does not have inbuilt ADC. If you want to interface some sensor, analog sensor to ADC means we definitely need the MCP 3008 external IC. Then what is PWM? Okay, what is PWM? What is pulse width modulation? Okay, pulse width modulation is the technology for whenever the motor, where any motors like stepper motor or DC motor, speed control technology, best speed control technology is PWM. Okay, whenever where it is everywhere, they used to only PWM technology for control the motor. Okay, but unfortunately, PWM is does not inbuilt PWM pin does not have in 8051. Okay, we can split the pulse width modulation. Okay, PWM is pulse width modulation. Pulsar, we can generate the pulse using some devices like crystal oscillator. In our lab, in engineering lab, also using one function generator. Function generator we easily create one pulse. Okay, then what is modulation? What is modulation means to merge the message signal and the carrier signal is called modulation. Okay, where it is used, like modulation where it is used means in FM, in radio, in FMs they used one frequency to transfer the data from one place to all places. They used one frequency. Okay, they used one signal. The signal is analog signal. Okay, they used the analog signal. Like analog signal, they speak some voices. The voice signal is the one analog signal. They give you one output, then that will be the analog signal, the message signal. Okay, then they have one carrier signal. Okay, carrier signal means we used one FM. 98.3 is the one FM. Okay, that FM they measured the message signal and the carrier signal. Okay, carrier signal is the 98.3 is the carrier signal. Message signal is some voices or some songs. Some songs are message signal, like analog signal. To measure the message signal and the carrier signal is called as modulation. Okay, then we have some towers in our areas. Okay, the top of the top tower, the top of the A1 blade, that blade is the receiver blade. In bottom we have one transmitter blade. The 98.3, that modulation, that signal will be transferred to receiver via transmitter blade. We have in our home, we have FM. We just fix the 98.3 mean the data will received from our FM. Okay, to match the message signal carrier signal is called as modulation. Mean split the message signal is called as demodulation. Okay, demodulation we get the song or voices of the FM person. Okay, modulation means to merge the message signal and the carrier signal. Okay, demodulation means split the message signal. It is called as the demodulation. Okay, this is called as modulation. Okay, then pulse we already know. We just create in controllers also. We have one oscillator. Via that oscillator only we create some pulses. Okay, every microcontroller definitely have one oscillator. Okay, that oscillator is called as crystal oscillator. Okay, crystal oscillator frequency means 10 to the power of 6. Okay, in 1 second they create they create 10,000 pulses, 10 lakhs pulses in at a 1 second. At a second, they create 10,000 lakh pulses. Then, because that the controller will work very fastly. Okay, we give every second we give 10 lakhs pulses for controller. It will it will very fast. Okay. Every controller you definitely have the crystal oscillator. The controller, every controller definitely have the crystal oscillator. The controller does not have crystal oscillator means the controller definitely not work very fastly. Okay. Using crystal oscillator means only the controller will work very fastly. Okay. Whenever the pulse width will be modulated with time means that is called as PWM. Okay. Whenever the pulse width will be modulated with the timing, that is called PWM, pulse width modulation. Okay. But unfortunately, 8051 does not have inbuilt PWM pins. But Arduino have 6 pins. PWM pins. Arduino have the 6-pin EWM. Via that pin, we easily control the one motor, any motor. We can control the DC motor, stepper motor using that pins because that pins have inbuilt PWM function. Okay. Then timer. Okay. Timer means we give some delay in program. Okay. If you are using one program like LED blinking, if you want control the LED, okay, 5 seconds on and 5 seconds off. Based on that, timer will work on that programming. Okay. But unfortunately, 8051 does not have inbuilt timer. Okay. Here also we use one. Everyone know the timer circuit like IC555 is the one timer circuit. Used to that circuit only we will give some delays in 8051 microcontroller. Then UART. Okay. UART mean universal asynchronous receiver transmitter. Okay. Why UART is the most important controller means before we using Arduino, if you use one program, Arduino example, I give the example, Arduino IDE one is there. Okay, if you using Arduino IDE means we using some program. Okay, some program like we just give the LED program, then we upload the program to microcontroller via one cable. That cable is UART cable. Via that cable, we easily upload the code to microcontroller. Okay, that is the UART communication. But in 8051, we have used two softwares. Okay, first we create the programming in one software, then we upload the code. We upload that code to microcontroller using another software. That is very difficult. Okay, two software is very difficult. Using that software, external software, we just upload the program to microcontroller. That software have one dumper. Via the dumper only, dumper means programmer. Via that programmer dumper only, we just upload the code to the microcontroller. That is very difficult. Okay, but using UART cable means we easily done the program. We easily upload the program to microcontroller. These are drawbacks in 8051 microcontroller. Then these drawbacks are rectified in PIC microcontroller. Okay, 8051 have lots of devices. 8051 family have lots of microcontroller like AT89S52, AT-C951, like lots of microcontrollers. Okay. Then what is the difference between that microcontroller means? Like we have some mobiles like Redmi 0, Redmi 6, Redmi 7, Redmi 8, like that. That is based on that RAM memory. Like controller also have one RAM and ROM. Okay. Then IO pins, input output pins. Okay. That pins are changed. Like if you have lots of ROM in, we just give like Redmi 6A only 64 GB RAM ROM. Then Redmi 7 means 128 ROM. Okay, based on that RAM ROM only the family will differ. Okay, then we propose to like PIC microcontrollers. PIC microcontroller has some drawback. The 8051 have 256 instructions mean definitely that in those instructions are definitely minimized in the PIC microcontroller. Okay, minimized like PIC microcontroller have only part instruction set. Okay, part instruction. Then PIC microcontroller have 5 ports like port A, port B, port C, port D, port E. PIC microcontroller have 5 ports. Every port have 8 pins. PIC 16 of 877A is the famous microcontroller in PIC family. Okay, PIC family also have lots of microcontrollers, but famous microcontroller in PIC means PIC 16 of 877A. That microcontroller have 5 ports like port A, port B, port C, port D, port E. Every port have 8 pins. Totally PIC microcontroller have 40 pins. Okay, in that port C is used for ADC. In PIC microcontroller, port C have inbuilt analog to digital converter. Then PIC microcontroller have 14 to 18. These 5 pins are inbuilt PWM function pin. Instead of timer IC555, they used real-time clock. In PIC microcontroller, in Arduino also have real-time clock. Okay, you using real-time clock means timer circuit does not need. Okay, then UART communication. Then PIC microcontroller does not have UART communication. Okay, in PIC microcontroller they used one software MPLAB IDE for creating the program in software. Okay, and create the one X file. That X file will be the output of the software. Then that X file will be transferred to microcontroller via PIC programmer. Definitely, whenever you just upload the code to controller means in PIC microcontroller, we definitely need the PIC programmer. That is the very difficult one. Okay, so PIC microcontroller have one drawback like UART. Then these two microcontrollers are 8051 and PIC microcontroller. Those two microcontrollers are called as CISC. CISC means complex instruction set computer. These two microcontrollers called as complex instruction set computer. Then these instructions are reduced with and created like advanced RISC machine. ARM is the next microcontroller, is called as advanced RISC machine. Okay, RISC means RISK is not RISC, reduced instruction set computers. Reduced instruction set computer. This is called as ARM, reduced instruction advanced RISC machine. In this microcontroller also every drawback is rectified. ARM microcontroller does not have any drawbacks, but the cost is the matter. The ARM microcontroller based if you using ARM based microcontroller means that will cost will be 3,000, 2,000 to 3,000. Okay, then only they proposed cost effective, user friendly, easy programmable memory like Arduino microcontrollers. Okay, Arduino micro. Then they created one microcontroller like ESP8266. Okay, Arduino microcontroller ESP8266. These are the cost effective based on Arduino IDE software. Arduino IDE software only have 10 to 15 instructions only. Arduino IDE software have 10 to 15 instructions only. But before the using controller means they have lots of instruction set and they have some drawbacks. Then we choose, then only Arduino is most famous. Arduino microcontroller cost is 500 only. Okay, then it is user friendly. We easily programmed in Arduino. We also used Arduino IDE software for send the data to cloud. Okay, but we use the ESP8266 microcontroller. Why Arduino does not have Wi-Fi connection? If you send the data to internet means if you send the data to cloud means we definitely need the internet. But Arduino does not have, Arduino microcontroller does not have Wi-Fi facility. Then Arduino is proposed to like ESP8266 microcontroller called as Node MCU. Node MCU also like as Arduino, but ESP8266 microcontroller like ESP8266 Wi-Fi module. We are using that Wi-Fi. We easily send the data to cloud. If you've done your project in IoT means mini project or main project means definitely we go for ESP8266 microcontroller. This is also like Arduino. Okay. Using Arduino IDE software we easily programmed in ESP8266 microcontroller. Okay. This part will be the introduction part to the microcontroller. Okay, where it start from like that. Now we finished with the Arduino microcontrollers, then ESP8266 microcontrollers. Okay, if you're doing your projects in internet means you definitely do your projects in ESP8266 microcontroller. That microcontroller cost is 400 only. It is user friendly also, but if you do your project in also Raspberry Pi also. Okay, Raspberry Pi also have inbuilt Wi-Fi, but Raspberry Pi's cost is high. Raspberry Pi start from 3000. Okay, to cost is high. If you are using ESP8266, it is user friendly and cost effective. If you go for programming in Raspberry Pi means you definitely need the Python programming. Okay, or you are using Arduino IDE based on ESP8266 microcontroller means you definitely use the embedded C programming. Okay, then these are some applications in IoT. Okay, now I will give some explanation about applications in IoT. Then I will start some programming explanation to you in IoT. I will give some program explanation in IoT, how to start the IoT, how to read the data from sensors, then how to upload to the code, how to upload to the cloud. I will tell. Okay, first is these are some applications in IoT. IoT have lots of applications. I will give some these applications only. Okay, first is transport and logistics. Okay, first is transport and logistics. Okay, this is used for goods tracking. Okay, first we have one microcontroller. Okay, and we used to track the truck or car or motorcycle means we definitely need the GPS. GPS means global positioning system. Via GPS is first communicate with satellite. Via that satellite we easily define the location of the motorcycle, car or truck. Okay, using GPS means we easily monitor the track. Okay, how you monitor? Before you using internet means we just transfer the message to controller. We have one controller to read the GPS. GPS means that track the vehicle. Okay, then that data will transfer to user. Like the user means one mobile phone using GSM. Before internet, we use message. Via message, we just give the output in message. Okay, if you are using internet means we easily monitor the vehicles using internet. How means first we read the data like GPS data, then the data will be uploaded to one server, a server or cloud. Okay, if you are using that cloud means we easily track that vehicles. Okay, I will give one explanation. If you are choosing one train, okay, if you are choosing one train means based on that train, that train you have one number. You just give that number in Google Bin. They will track the train usually. How it means the train have one controller or any other things, one processor. Controller process same thing. I have one controller. That controller read the train GPS, then the data will be uploaded to one cloud. Okay, if you are using that cloud means easily we can monitor that track. Okay, track or goods tracking, everything based on the GPS, global positioning system. Then like these also the kids and senior tracker, wearable kids and senior. This also have one GPS tracker. These two are same concept. Then we go for smart metering, smart grid management. Okay, in this concept, we have two sensors. Okay, voltage sensor and current sensor. Based on this sensor data, we easily read our meter, like smart meter. We easily read our smart meter. Smart meter means we read those data, voltage and the current sensor. We read the voltage and the current we used in our home. Then the data will be uploaded to cloud. Means we easily monitor the data using the cloud. That is like smart metering and smart grid management. Then smart cities. Okay, then parking sensor and waste management. What is parking sensor? Okay, in smart city based, one mall is there. Okay, one mall is there means that mall is definitely a parking facility. Okay, before we enter that mall, we just know the parking is available or not. So we definitely in also a one controller. That controller is read the parking facility data. That data will be uploaded to cloud. Means we easily monitor the parking facility using one server. Based on that server, we definitely know the parking facilities available or not in that mall. Okay, then smart building. Okay, smart building means before that we use the smart building operation. We using Bluetooth. Okay, like one fan is, I give one example. One fan is fan A, one controller, and we have one remote. Okay, smart automation I will tell using Bluetooth communication. Okay, before internet we used the Bluetooth communication. Okay, fan A, one controller. Okay, and remote also a one controller. Whenever you click the button in remote, the controller will transfer the data to like fan controller. Okay, whenever the fan controller read the some data using like on, like that means the fan will be operated. Okay, you see Bluetooth means that will be restricted like 10 meter to 20 meter only. That will be restricted to 10 meter or to 20 meter only. But if you are using cloud means you have one controller to control that data. Okay, whenever using cloud means we definitely control the fan. Whenever where it is from your world, we easily control that fan using cloud. Okay, because if you want to control that fan using cloud means you definitely need some internet only. Based on that internet, we can easily control the fan from anywhere in the world. We easily control the fan using anywhere in the world. How it is mean the in home we have one controller. That controller definitely need some internet. Okay, that controller has some internet. That controller especially have one web server. Okay, the controller definitely have one web server. Via that web server, okay, whenever that controller read that every time the controller read the data from cloud. Okay, every time that controller read the data from cloud. Whenever you out of from the home, you just using via that cloud, you just on the data or off the fan means the data using the cloud data will be given to the microcontroller. The microcontroller will be run based on that cloud data. The fan will be off like that. But if you are using Bluetooth means the distance will be restricted to 10 meter to 20 meter. But you are using cloud means we cannot define the distance. Okay. In the world, easily we can control the home appliances using internet. But definitely the controller gave some internet, but we also have some internet. Via internet, we easily control the devices from anywhere in the world. Then industrial. Okay, the same concept also industrial. If you control some industrial appliances, if you control the motor, everything will be using internet means we can easily assist the industrial using one cloud. Okay, then this is industrial monitoring. Then environment monitoring. Environment monitoring means what is the temperature and humidity. These are data in environment monitoring. Okay, what is the temperature, what is the humidity. Okay, first we read the temperature and humidity data via one controller. Okay, then based on that controller, we just upload the data to cloud. Means we can access the data anywhere from the world using internet. Then agriculture field monitoring. Okay, agriculture field monitoring means soil moisture sensor or temperature sensor, then water level sensor. Okay, okay, one land is one agricultural land definitely need the water. Okay, okay, we can easily monitor the land soil using soil moisture sensor. Based on that sensor data, we can easily control the motor. Okay, the land is does not have water means using internet we just turn on the motor in our mobile phone. Using mobile phone, we are easily control the land motor using internet. But definitely we need the internet. Okay, what is the benefits internet means? Definitely we need the internet. Immediately we need the one cloud. Okay, using that cloud, we easily control the devices and monitoring the devices. Based on the devices, the application will vary. Okay, if you are using voltage sensor and current sensor means like that is smart metering. Okay, if you are using GPS tracker means that is one tracking device. If you are using environmental monitoring like temperature and humidity means that is environment monitoring using IoT. Okay, IoT is used for monitoring and controlling. Okay, these are some applications in IoT. Then we go for which microcontroller is used for IoT. I will tell what is that microcontroller, how to use that microcontroller, how to program in microcontroller, everything I will tell. Okay, this is the introduction part. Then only we go for programming. Okay, first we collect the data like GPS or sensors, everything. We first collect the data using one controller. Okay, then that data will be uploaded to cloud using some internet. Okay, how will we give the internet to that controller? How we give internet to that controller? Everything I will tell. Okay, then IDE. Okay, every time I will tell IDE. What is IDE? Is the most important thing. Okay, and integrated development environment is a software application that provides comprehensive facilities to computer programmers for software development. And IDE normally consists of at least a source code editor, build automation tool, and a debugger. Okay, what is the difference between compiler and IDE? Okay, compiler. If you're using one compiler, like compiler means C program, like Turbo C, C++. These are some compilers. Okay, that compilers only give software output only. If you have some error means the compiler will give some error point and it will give output via that software only. Okay, but if you are using one controller means definitely we go for hardware. Okay, I already told if you are using one IDE, based on that program only, the controller is work. If you are using some programs, based on that program only, the controller will work. So we definitely need the one IDE in controllers. IDE is then source code editor. Okay, compiler also a source code editor. Source code editor means we using source code editor, we put the program in controllers. Then this is the most important thing in IDE, build automation tools. Via that only build automation tools. Via that only we easily upload the code to controllers. Via that only automation tools. Via only we upload the code to the microcontroller. This is introduction to IDE. Okay, if you are choosing ESP82 microcontroller, ESP8266 microcontroller is the IoT module, like Node MCU is the IoT module. They have inbuilt Wi-Fi. Okay, how to I will tell how to access that Wi-Fi and how to read the sensor data and how to upload the code, how to upload the data to cloud. Okay. Then this is the Arduino IDE diagram. This will be the code area. This will be the code area. Okay, this will be the code area. This will be the verify. Using that verify. Verify means this allows you to compile your code to code the Arduino understand. Any mistakes you made in the syntax of your code will be shown in the info manual. Okay. This Arduino IDE have some instruction. That will instruction via that if you give based on that instruction only, the IDE will works. Okay, that will be tell here. This allows you to compile your code to code the Arduino understands. Arduino have some language. Okay, if you are giving a program using that language means only using that instruction set only, we will give program to that microcontroller. Okay, but Arduino IDE have like 10 to 15 instruction set only. Okay, info panel. This will be the info panel. Okay, this will show any errors during compiling or uploading code to your Arduino. This will be show you any errors during compiling or uploading. Code area. This will be the code area. This is where you will type all your code. Okay, then upload. This will be the main function in IDE, Arduino IDE. This does the same verify, but will send the code to your Arduino if the code is verified successfully. Okay, the code does not have any error mean this via this option we easily upload the code to controllers, any controller like ESP or Arduino. Then serial monitor. This will open a window that allows you to send text to an from an Arduino. We will use this feature in later lectures. Okay, I will tell. This will be this is the one Arduino IDE. I will open the Arduino IDE. Okay, this is the Arduino IDE. Wait. Now I will share the Arduino IDE software. This is the Arduino IDE software. Okay, this will be the source code editor. Okay, using this code editor, we read the sensor data. Okay, sensors data. Okay, first sensor data will be read from controller, then only it will upload to cloud. Okay, I will give one simple explain. Okay, how to read the one analog sensor. Analog sensor means like temperature, like gas or water level is the one analog value. Okay, I will give the explanation about. First, I will give the ESP8266 microcontroller. Then I will come for programming. Okay, this is the Arduino IDE software. This will be the verify. This will be the upload button. Tools, using the tools. First, we fix the board. First, we will fix the board. We are using Arduino Uno means we will use the Arduino Uno, but we use the ESP8266 microcontroller. So based on that microcontroller, first we fix the board like ESP8266 microcontroller. Okay. This will be the microcontroller is used for IoT in lots of projects in industries and college students also using this microcontroller. This is the cost effective and user friendly like Arduino. Okay, if you already done your program in Arduino means you easily use this module also. But no problem. I will also explain about how to program in Arduino IDE everything. This will be the microcontroller is used for IoT applications like Node MCU ESP8266. Okay. ESP8266 the Naveform microcontroller designed by ESPRESS system. ESPRESS system is the developed the ESP8266 microcontroller. This will be self-contained Wi-Fi networking. It will be controlled Wi-Fi networking. Arduino based on ESP12E and fully programmable. It's the main important thing. It will be worked based on program only. Every microcontroller is worked based on fully programmable. Every microcontroller is definitely worked based on programming only. Okay. It is also development and prototyping board. It's also used for development and prototype method. Specification. This microcontroller has some specification. Every microcontroller gives some RAM and ROM. Okay. This is the input voltage is 3.3 volt and the current consumption is 10 to 170 milliamps. Flash memory is 16 MB. Flash memory is the ROM. Flash memory is called as ROM memory, read-only memory. 16 MB. Okay, this is one processor like Tensilica L106 32-bit. This is based on 32-bit microcontroller. Okay, this speed is 80 to 160 megahertz. So working speed is 80 to 160 megahertz. RAM is 32 KB. The RAM is 32 KB. And this microcontroller GPIO is 18 pins. GPIO means general purpose input output pins. Okay, general purpose input output pins. 17 multiplexed with other function pins. Digital pins. It saves 17 digital pins. Okay, but its microcontroller gave only one ADC, analog to digital converter. Okay, in this microcontroller also, if you want interface with 2 analog sensor, 3 analog sensor means you definitely need the MCP3008 IC. MCP3008 based on that IC only, we can 2 or more sensor interface with ESP8266 microcontroller means we definitely need the MCP3008 IC. But if you're using only one analog sensor means we does not need the MCP3008 IC. Okay. Based on this microcontroller only, we easily read the data. Okay, then this will be the pin diagram. Okay, this pin diagram based on that only. We can program using pin diagram. Definitely we used one microcontroller. We definitely know about the pin description. Based on that pins only, we can program in that microcontroller. First, definitely if you are using one microcontroller means definitely you need to know the pin description about that microcontroller. Okay, based on that pins only, we can program in that microcontrollers. Okay, then this will be the ESP8266 microcontroller. This microcontroller here inbuilt Wi-Fi. Like this microcontroller here inbuilt Wi-Fi. Using that Wi-Fi only, we can easily upload that data to cloud. Okay, if you upload the data to cloud means we can access the data in anywhere from the world. We can access the data in anywhere from the world. But definitely we need some internet from transmitter section and the receiver section also. We definitely need some internet. Okay, these are the pin instructions. GPIO 14, 12. These are the digital pins. Okay, digital pin means 17 digital pins here. Then ADC is a ADC 0. A0 is the analog to digital converter. This microcontroller also A1 inbuilt ADC. Microcontroller 10-bit ADC. Okay, if you using already digital means 0 sans 1. We can easily define the digital value. But how to define the analog value? So already told this microcontroller gave one ADC. But what is that value? Okay, this microcontroller is a 10-bit ADC. This microcontroller gave 10-bit ADC. 10-bit ADC, inbuilt ADC. Okay, what is the most value and what is the least value? Means this microcontroller 10-bit ADC, okay, we can give one formula 2 power n. This formula is used for 2 power n. This formula is used for we define the values. We define the values for analog to digital converter. Okay. 2 power n. Using this formula we are only we define the analog values. Okay, 2 power n is the formula. Okay, this microcontroller gave 10-bit ADC. 2 power 10. 2 power 10 means 1024 is the total value, but the least value means 0. Largest value means 1023. We can define digital mean 0s and 1. Okay, this microcontroller have 17 digital pin. That digital pin output will be 0 or 1. But if you are using analog to ADC, A0 pin means that will be the output will be from 0 to 1023. Okay. Okay, this microcontroller here 0. This pin here in this microcontroller A0 pin here the output value like 0 to 1023. Okay, if you monitor the room temperature using that pin means the room temperature value will be 30 to 33, 20 to 33 degrees Celsius. Via that pin, we easily monitor the temperature. But GPIO 1, 3, like digital pins via, we cannot monitor the analog values. Digital pins via, we cannot monitor the analog values. Why? Why means digital value. That pins does not have ADC. That will give the output like 0s and 1 only. If you interface with 2 or more sensor with ESP8266 means we also definitely need the MCP 3008 external ADC IC. That ADC IC also here 10-bit ADC IC. That's also 10-bit ADC. That value is also from 0 to 1023. Okay. Okay. This microcontroller here 17 pins, digital pin, and ADC1 analog pin. That will be the VIN is the input pin to this microcontroller. This microcontroller here 3.3 volt input, and these will be the MOSI, CS, MIS, OSLK. This is the SPI communication. Via SPI communication only, we externally read the data from MCP 3008 IC. If you are using only one analog sensor in ESP8266, no problem. But if you used 2 or more analog sensors in ESP8266 microcontroller mean we definitely need the MCP 3008 via SPI communication only. Via SPI communication only, we can read the data from MCP 3008 IC. Okay, the MO master out, slave in. This will be the clock signal, and master in, slave out. This communication via only we can has is the MCP 3008 IC. Okay, we also give power supply via this like one plug also, like USB cable via also we can easily upload the code. Using this cable via we easily upload the code to this microcontroller. Also UART communication. This microcontroller on UART cable. Via that cable we easily upload the code to this microcontroller. Okay, then Arduino microcontroller does not have inbuilt ESP82. Arduino IDE does not have inbuilt ESP8266 board package. First we download the package using URL. Using this URL only we can download the ESP8266 package. Okay, first we download the ESP8266 board package means then only we can upload the code to that microcontroller. Now does not have ESP8266 microcontroller in board. First we can download using boards manager. Okay, first we will give the preference via. First we will give the preference. To download the ESP8266 package means first we will give the using preference. Using preference we will give package, some package. First we upload the package, then we will give okay. Then we go for boards manager. We already give the preference in URL via URL. Okay, based on that URL, we give download the boards manager. Right? ESP8266. Okay, first we download the packages. Okay, using that packages only, we can access the ESP8266 microcontroller using Arduino IDE software. First we download the ESP8266 package. Then only we can access the ESP8266 microcontroller in Arduino IDE software. It takes some minutes. Okay. Then this is already done. Click to tools and boards manager to access this panel. Scroll down to ESP8266 and community and just give the install button. Means the installation will start in ESP8266 microcontroller. Then we give for ESP8266 and generic ESP8266 is the module. Then we fix the data. Using the data only we can use the microcontroller. Okay, based on that microcontroller only we will first we fix the microcontroller via board, then we fix the port. Then we will give the frequency. Via that frequency only the data will transfer to system and that microcontroller. Okay. Now download. I'll download the like ESP8266 board. First we does not show the Arduino, only show the Arduino boards only. Now I download the ESP8266 board. ESP8266 are lots of board, but generic ESP8266 is the basic model. ESP8266 based on that model only we can upload the code to microcontroller. First we download the boards using. First we give the preference in based on that URL. Preference will give. Then I will go to the tools, board and boards manager. Then I will give ESP8266 and this you like already installed. Via that only we can install. Arduino IDE is also open source software. We can easily download using Google. We just type the Arduino software means Arduino IDE. Using lots of software available, we can easily download using web pages. The Arduino IDE is the open source only. Okay. Then this is the setup function. Okay. Then this is the setup function. First we download the board, then we will fix the board using boards manager, and we will fix the some frequency. Okay. ESP8266 the modules, the module we are going to use. So we fix the generic ESP8266 module. Then we fix the frequency like 80 megahertz. Okay. Then this is the program for read the data, the upload to the cloud. Okay. First we give some YADRA files like SPI communication and Wi-Fi NINA. The Wi-Fi NINA is used for to connect the devices in ESP8266 microcontroller. Wi-Fi NINA is used for connect the devices to connecting the device via Wi-Fi. So Wi-Fi NINA is used for connecting that microcontroller using Wi-Fi. Then we will give the SSID and password. Okay, we have internet via our mobile. How do you give the internet to that microcontroller? Mean we does not have internet, mean we just ask our friend to turn on that your friend hotspot. Then we just on our Wi-Fi. Then we will give your friend also have your friend definitely have one SSID. SSID means like one mobile like Realme 6 and have some password. Then in your mobile phone you are using Wi-Fi, means they shown available Wi-Fi network, and you will fix your friend network, and you enter the password, means based on that password the device will be connected. Same thing only happens here also. Okay, first we will fix the SSID and the password. Our SSID like Moto E4, and give password in SSID and the password. Then I will give one integer like status and Wi-Fi, ideally status, and I am using Wi-Fi client. Okay, here I am using HTTP protocol via we post the data to cloud. Okay, HTTP data via we post the data to cloud. Okay, first we fix the SSID and the password. Then I will give here also I will give the this is the string query, means this query will be uploaded to cloud. Okay, then I will fix the baud rate. This is the baud rate used for transfer the data to controller and system. First the data read by controller, also printed in CPU also. CPU means we have one serial monitor. Okay, whenever if you want to print the data using serial monitor, definitely need the serial dot begin. Then I will trying to connect the Wi-Fi. First Wi-Fi communication Wi-Fi module failed. Whenever the available device not the SSID password does not available, mean it will give error like communication with Wi-Fi module failed. Then it will be attempted to connect Wi-Fi and give the SSID and password. Based on the SSID, they print the password, and based on the SSID and password, the device will be connected. SSID means like your SSID and your password. Okay, then this data, this is used for sorry, this is used for post the data to cloud. Okay, we just using HTTP protocol. HTTP protocol we are easily upload the query, but here client print query. This query is the data, like here is a query, string query, temperature, humidity, pressure, and wind. This is the some sensor data. Okay, that data will be uploaded to cloud. This is the string query. First we connected the IP address. Based on the IP connected, then insert MySQL. MySQL means it's the one database. MySQL is the one database. That database worked based on PHP language. Here front end is used for embedded C program, back end is used for PHP and HTML and HTTP protocol. Front end is the embedded C programming, back end is used for PHP and HTTP protocol. PHP and HTTP protocol via we create the MySQL database and we will give some host address. Okay, this host address we used for this every MySQL database have one host address. That address will give. Then via that print like application from URL encoded via in this command via the data will be uploaded to cloud. Okay, then we client read. We read the data from controller. The data will be client read. That client read means the data will be uploaded to cloud. Loop will the condition will be every time will be executed. Okay, based on this program only the data will be uploaded. Simple thing. First we will give our SSID and password and we read the sensor data. I will tell how to read the sensor data in Arduino. I will tell. Then based on HTTP protocol and insert MySQL database via we upload the data to cloud. Okay, first we definitely fix the internet. We will give the internet via mobile phone. Based on that internet only the data will be uploaded to cloud. Okay, now I will tell how to read the data, sensor data from controller. Okay, like every controller, if you are using Arduino also same program, ESP8266 also same program, but Arduino have lots of analog to digital converter pins, but ESP8266 have only one analog to digital converter. If you want to read the 2 or more analog sensor pin, we definitely need the MCP3008 external ADC IC. Okay, now I will tell how to read the sensor data in Arduino IDE software. Okay, this is the Arduino microcontroller, Arduino IDE. Okay, like ESP8266 microcontroller A, only one analog to digital converter. That pin will be that pin is called as ADC0, like A0. That pin is called as A0. Via that pin we read the sensor data. First I will tell one water level, how to read the water level sensor. Okay, first I interface with the water level sensor to ESP8266 microcontroller. First I will tell the program how to read the sensor data. Every sensor have only 3 pins only. Every analog sensor, some different sensor only like 4 pins and 5 pins. Basically every sensor have only 3 pins. Okay, every sensor have 3 pins. First we will give the ESP82 every microcontroller based on one program only, one IDE based only, that microcontroller will work. First we define the pin. Which pin we are going to use the ESP8266 microcontroller. If you are using digital sensor like IR sensor, like these are sensors are digital sensor, this output will be based on 0 cents only. So first we give the pin initialization in every microcontroller. First we give the pin initialization. Which pin we are going to use in that microcontroller. So ESP8266 only one analog to digital converter like A0. I will define water is the variable, and I will give the input like via A0 pin via we read some data. So I will give the A0 pin, then I will fix that pin. First I will save that. This will be used for save. That file is used for save. I will give water sensor, water level sensor, and I will compiling this. It does not give any errors. Done compiling. First I initialize the pin, then I will tell that pin will be the input pin, output pin, input pin or output pin. Okay, what are the devices are output device? I will tell like buzzer and motor, like an LED. These devices are some output devices. Okay, whenever you give the voltage to that, whenever you give the voltage to buzzer or LED buzzer, you give the voltage to buzzer means the buzzer give some alert sound. If you give a voltage to LED means that will glow like that. The LED will be on. The LED does not give any values to controller. That LED does not give any values to controller, but water level sensor it will give some values to controller. So sensors, most of all every sensor will be the input. Okay, input to the controllers. LED, buzzer and DC motor, these devices are output to the controllers. Why these devices are output means this device does not give any values to the controller. Okay, now I will tell like this will be the one instruction like pin mode. Via pin mode only we can define, we can tell the device's input or output to the microcontroller. Pin mode is the one instruction. You give the pin mode like pin mode, M is capital, that is the instruction. Okay, you definitely give pin mode like M is the capital only, the data will be know the Arduino IDE software. If you does not give, if you give small means, now I will give like pin mode water. Water is the variable I will create. Water is the variable. A0 pin is I am going to use. Okay. Then water, comma, input. Okay. Now I compile, done compiling. Now I will give pin mode is small. I will give pin mode to small means now it will give error. I does not know pin mode. Pin mode was not declared in the, like that gives some errors. Why I mean like pin mode is does not know IDE. That is one instruction. You give pin mode mean definitely you have to give M in capital letter only. Okay. They give the error like mean pin mode was not declared in the scope. Okay. Now while the capital letter is, now it will give, now it does not give any errors. Pin mode water comma input. Then I fix some serial dot begin 9600. I will fix some baud rate. Why this baud rate is need means the controller, this data will be uploaded to microcontroller via one cable. Okay, so the transmitter definitely need one baud rate and receiver also definitely need one baud rate. Based on that baud rate only the data will transfer. Okay, first the data will upload to microcontroller via 9600. Then this data will be read from controller. Then it will be uploaded to, then it will give to computer means the data readable from this serial monitor. Now serial monitor does not connected. I will connect, wait. Now I will connect one device to one port, so it will give one port like this. Now I will disable that port. Now it does not show any port. Okay, now I will connect one controller. They will give one port. Okay, beyond using that port via only we can upload that code to controller like Arduino or ESP, every A2WC, every microcontroller. First, then using that we read some data. This data, whatever the data you printed in this code means that data will be printed in this serial monitor. This is the serial monitor. Okay. First then I will tell, I will fix that sensor like water. I will fix the one sensor and the analog sensor. So I will give the analog pin initialization. Then the sensor will be the input. I will tell the sensor is the input to controller via pin mode function. Then I am using serial.begin. Serial.begin is also one instruction. Okay, definitely we will give S is capitals and serial.begin. Before using begin means we definitely give one dot. Okay, this will be the acceptable for Arduino IDE software. This is one instruction. You fix the baud rate via this command only. This is the one instruction. Okay, then void setup. Okay, void setup means, okay, first I will tell, this is the void setup. Whatever the data you given in this email, it will run only one time only. Put your setup code here to run once. If you want to run the data repeatedly means, run the data means the controller repeatedly read the data from sensor means you give the code to void loop. You definitely give the code to in void loop. Okay. Now I am using void loop function. There is the setup function. First I will fix the one baud rate and I will give the one sensor is the input sensor. Then I am creating one variable, one integer variable. Why I am creating integer variable means the sensor data will be the some integer number. So I am creating one integer variable like a. Why I am creating one variable means I want store the data in one variable. So I definitely need one variable. Some sensor data like sensor data is readable from controller. That data will be stored in one variable. So I definitely need one variable. I am creating integer. Why I am choosing integer means that sensor data will double some numbers. So I am creating integer. Okay, like integer like int. This program is based on embedded C program. So only I am like as define and the integer like will define like int. Okay, then I am creating another instruction like via analog read. Via analog read, we can read analog values from one pin. Okay, which pin we are going to read the data? I already initialize A0 like water. Okay, so I will give water. Now this function will run repeatedly. Okay, whenever the function is fixed at some baud rate, based on the baud rate, the data will transfer to controller to system. Then I am creating one variable to store the data from sensors. Okay, then I am printing that variable in serial monitor. So I will give another instruction like serial.println. Okay, this instruction we print the data. Which data you are going to print? You already know some language like Python or C. Whenever the data you give double quotes means that data will be printed in monitor like water level. Water level. Then serial.println. Ln means new line. Then water level A. This is the one basic program. It's the most important program too. Whenever you read the sensor data via this program only. Okay, if you are using any sensor like temperature sensor, gas sensor, every sensor is based on this program only. Or if you are using one digital sensor, means we definitely like IR, like define IR equal to first pin. First pin means GPIO 1. Then I will give the this one is input or output pin in the IDE. So I will give pin mode function. Based on that function, I will give input. Then I am creating another variable to store the data. Then I will give, this is the digital. IR sensor is used for object detection. It will detect object is detected or not detected. It will object detected means it will give like value 1. If the object does not detect means it will give value like 0. So it's the digital sensor. So I am only fix the digital pin in microcontroller like ESP digital pin. You 70 digital pins. Then which pin I am going to use the in that output? IR sensor also have 3 pins only. Every sensor have definitely most of the sensor have only 3 pins only like VCC. VCC means 5 volt. Underground and this is the output pin. Okay, VCC will be connected to controller input voltage, and the ground will be connected to controller ground. Then the output pin will be connected to, like we already give in programming, like IR sensor is a digital sensor, ESP8266 have 70 digital pins. So I will fix the pin that will be called as pin initialization. Based on that pin only, the data will be read from controller via programming. Then I will fix another variable, digital read IR. Then serial dot println this data. These programs we easily read the analog sensors value and digital sensors value. Okay. Then we use to upload the code bin. We first fix the board manager like ESP8266 microcontroller. Then we fix the frequency like 80 megahertz. Then we upload the code bin. The data will be uploaded. The data will be uploaded to this program will be uploaded to controller. That controller read the water sensors and IR sensor details stored in controller only. Stored in controller only. If you want to the data uploaded to cloud means we definitely need this code and one internet, everything. We definitely need internet and these things. We fix the SSID and password in programming and read the data and upload the data to cloud. Okay, this is the explanation about how to read the data from controller and how to upload it to cloud. Okay, if you are using analog sensor means you fix the analog pins. If you are choosing digital sensor means you will fix the digital pins. Okay. Then I will give one project explanation. And I will give the one project explanation in IoT based project. Then we finish the section. Okay. Then this is the one project like mini project or major project in engineering student. Home monitoring and automation using IoT. Okay. Here I am using two microcontrollers. Why I am using two microcontrollers means ESP8266 microcontroller A, ESP8266 microcontroller A, only one analog to digital converter. ESP8266 microcontroller A does only have one analog to digital converter. So I am using Arduino Uno as a main microcontroller. I am reading this data like temperature sensor, gas sensor, and a fire sensor. These sensor, temperature sensor is analog sensor, gas sensor is analog sensor. This data will be changed with time. But fire is the digital sensor. Fire sensor detected, the fire is detected or not. Okay. Based on the data, this data will be read from Arduino microcontroller. Then it will give to the ESP8266 microcontroller. Based on this data, I can control the devices everywhere from the world. Okay, I can control the data like one fan or lamp. I read the home monitoring means I read the home values like home monitor, temperature sensor and gas sensor, fire sensor. You already know about how to read the sensor data in Arduino IDE software. Then the data will be uploaded to ESP82 microcontroller means based on that data we can access the home devices like lamp and fan. These are our prototyping project for final years. This is one simple example for IoT based monitoring and automation. Okay. Okay. Thank you for valuable your time spending with me. Okay, thank you so much. Thank you so much, Arupadi Video Institute of Technology, for giving this opportunity.
Thank you, sir. Thank you so much, sir. Students had benefited a lot from this. Students, if you have any question, you can raise your hand now.
Ask with me. Okay. Yeah.
Students, if you have any question, please raise your hand or you can put it in the chat box.
Okay. What are the most used sensor types in IoT, sir? Okay. Based on that application, every sensor, like embedded, like IoT, like 50 to 100 sensors. Okay. Okay, based on sensor, we can program in Arduino IDE, then read the data. Okay, every sensor will be read every data, like every sensor will be interfaced with microcontrollers. Most used sensors means like these sensors are home monitoring, like temperature and gas and humidity. Agriculture field means soil moisture. These sensors has the most used sensor types in IoT. Okay. How can we measure voltage using sensors? We have some circuits. Okay, using that circuits, or we have one sensor like voltage sensor. Okay, that sensor also have only 3 pins only: ECC, ground, and output pin. We can give some program to read the data from that voltage. Okay, are you using any other circuits like simple circuits? Based on that circuit, we can easily read the voltages from devices. Based on that program only, the controller will work. What companies are working on IoT? Like lots of automotive companies are worked on IoT. Like I am first time already told like that vehicle tracking like that. Based on that topic, lots of automotive companies like Bosch and APTIV like and Electrobit. These companies are already worked based on vehicles monitoring and vehicle tracking like that. Some research concept means every concept is research. These please suggest some research concepts in IoT. Like this, now the industries are some automotive industries are based on vehicle tracking and how many passengers in that bus. Like that only the research is going. So you definitely go for like automotive field means, or like the you're doing your be like biomedical means you're going for some patient monitoring devices. You first ma'am told like that the patient data will be the read by like temperature data, and the data will be uploaded to cloud like that. You also go for like patient monitoring using IoT like that. Nowadays the patient monitoring using IoT will be defined only prototype only. Okay, real time is now is very difficult. So if you are doing your research in patient monitoring like that means, well, then which sensor detect the breathing level, sir? Like breathing level means like using SpO2 sensor. Like SpO2 sensor is the one sensor is used for breathing level and heart rate measuring. SpO2. Any other questions or any other queries? Wireless battery free, sir, which sensor? Okay, battery does not based on sensors. Okay, battery is one device. So wireless battery free. It will be developed some circuits like converters, like boost converter like that. Based on the devices only, the battery will charge. Wireless battery free, sir. Nowadays wireless battery wireless battery means like that. If you hear that device say one transmitter and one receiver also. Wireless means wireless like that. RF radio frequency is the one wireless communication. Bluetooth also one wireless communication. Based on that communication, the will charge like that will be possible also. Like Bluetooth. Bluetooth is also good example because wireless charger means wireless one adapter, that adapter one transmitter, then receiver side one battery, the battery have one controller. Bluetooth transmit the energy and this Bluetooth will be receive the data. So it will be sorry, it will be stored from battery. Okay, what impacts will the IoT available for everyone? Okay, now is the everyone, every day we can run only on IoT only. Okay, if you chat or anything like YouTube, Instagram, Facebook, everything will be run on IoT only. It's a some good reasons, and also internet also have some bad reasons also. If you go for good things means you will be good, like that only.
Thank you, sir.
மேம் ஸ்டூடெண்ட்ஸ் கொஞ்சம் ஃபீட்பேக் ஃபார்ம் மட்டும் கொஞ்சம் ஃபில் பண்ண சொல்லுங்க.
நான் அவங்க மெயில் பண்றேன் சார். ஆக்சுவலி 2 ஃபீட்பேக் இருக்கு. I'll just mail them to sir. I've told them, sir.
ஓகே மேம், ஓகே, thank you மேம்.
Thank you, sir. Sir, just 1 minute. Santoshni ma'am.
Questions?
Yes, ma'am.
Ma'am, can we just wind it off, ma'am, formally?
Okay,
Yes,
ma'am,
ma'am.
wait,
Sure,
ma'am.
ma'am.
One student have one question. Okay, I will.
Okay, sir.
Okay, sir, how to connect the mobile Bluetooth to SpO2 sensor on detecting breathing level? Okay, this is the good question. Like how to connect the mobile Bluetooth to SpO2 sensor? We cannot directly connect the mobile Bluetooth to SpO2 sensor. Why means intermediately we have one controller. First controller have one Bluetooth module. First we connect the Bluetooth module with our module. Then the controller read the data. Like SpO2 sensor also have 3 pins only, VCC ground and one output pin. That via that output pin via only we read the data from that sensor data. Then the data will be transferred to controller Bluetooth. The Bluetooth data will be read from our mobile. Okay, this is the concept. Okay, we cannot read the data in embedded IoT based concept. We cannot read the data directly without microcontroller. Without microcontroller we cannot read the sensors data. Okay, recent IoT project means like lots of project is there. Agriculture monitoring and industrial monitoring and control industrial appliances. Then like shopping trolley used on IoT and aquaculture monitoring, water quality monitoring using IoT. IoT have lots of application. You only fix the application based on your domains. If you're doing you all biomedical means medical field project like patient monitoring, patient details. If you go research, if you go and search the details means it will very be useful for your projects and your career also. Ma'am?
Sir, yes, sir.
Okay.
I guess they are completed with the questions, sir.
Okay, ma'am. Yes, ma'am.
Can we wind it off, sir?
Yes, ma'am. Yes, ma'am.
Santoshni ma'am, you can take over, ma'am.
Okay, ma'am. Okay. Am I audible?
Yes, ma'am.
All right. So, as an end comment, I would like to sincerely thank our management for permitting us to conduct this workshop, and I would like to thank today's speaker, Mr. Mohana Sundaram sir, for sharing the valuable insights about the Internet of Things. And I would like to thank our HOD for her graceful support extended towards this workshop. And I would like to thank our fellow faculty members for their wonderful coordination. And finally, I would like to wholeheartedly thank all the participants from different institution and our institution for their presence and making this workshop a grand success. Once again, thank you all. Thank you. Please fill the feedback link. and submit it without fail. Thank you.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am. Thank you, ma'am. Thank you, students.
Thank you, sir.
Ma'am,
Sir, yes, sir.
can I leave, ma'am?
Yes, sir. Sure, sir. Thank you,
Okay,
sir.
okay. Thank you,
Feedback
ma'am.
form, I'll just ask the students to fill it and send it to you, sir.
Okay, ma'am. Thank you, ma'am. Thank you so much.
Thank you so much, sir. Yes, sir.
Thank you.